The second video is all about how to do differentiation, and we're going to have a look at a few different rules, with the first one here being the 2016 paper, and you've got a function being divided by a function. So the function divided by a function means that you're going to be using the quotient rule. So the quotient rule is when you've got something divided by something. So the thing on the top you call u, the thing on the bottom you call v. So if we say that u equals 4x, then du by dx is going to be simply 4. If v is x squared plus 5, then dv is simply going to be 2x. Now, if you're going to find dy by dx, you've got to remember it is given to you in your formula booklet. However, it's v du minus u dv. So v du is going to be x squared plus 5, that's v, times by du, which is 4, minus u dv, which is going to be 4x times by 2x, which is going to be 8x squared, all over v squared. So it's going to be x squared plus 5 squared. And notice that it says you've got to write it as a single fraction in its simplest form. So then what we do is we multiply this out. That's going to be 4x squared plus 20 minus 8x squared all over x squared plus 5 squared. So it's going to be minus 4x squared plus 20 over x squared plus 5 squared. And notice that on the top we've got something that can be factorized out. So what you might want to do is just factorize out the 4. So you've got 4 of minus x squared plus 5 over x squared plus 5 squared. But notice that we can't simplify because it's not the same on the top as the bottom. So it's about as simple as we can make it. So what we've got to do is we've got to find the set of values for this. So this is dy by dx. We've got to find where that is going to be less than 0. So the first thing we're going to do is we're going to set it equal to 0. Find out where it equals 0. Then we're going to choose either the left-hand side or the right-hand side. So if we're going to set a fraction equal to 0, what we do is we just set the top equal to 0. We're going to do 4 lots of minus x squared plus 5. I'm going to set that equal to 0. So divide both sides by 4. We've got minus x squared plus 5 equals 0. So 5 equals x squared. So if we do the square root of that, that's going to be plus and minus the square root of 5. So then let's see what happens when we substitute those values in. Obviously, if you substitute square root of 5 in to that, you're going to get 0. But what happens when you get above the square root of 5? So if we do above the square root of 5 here, that's going to be 5 plus, that's going to be minus, oh, let's have a sec. Yeah, so if you take x to be something way bigger than the square root of 5, so let's say like 100. So if we're going to do 100 squared, that's going to be something massive. Make that negative. Even if you plus 5, it's still going to be negative. So when x is bigger than the square root of 5, the top is going to be negative. The bottom, though, would be positive because you're going to square anything that makes it positive. So when x is bigger than the square root of 5, then dy by dx is going to be less than 0. However, because we've got plus and minus, what happens when x is going to be less than this negative square root of 5? So let's say it's minus 100. So it's going to be minus 100 squared is going to be positive. Then make that negative. Then when you add 5, it's still going to be negative. Whatever happens on the bottom is always going to be positive. So when x is less than minus root 5, dy by dx is going to be less than 0. So there you go, that's how you do that one. Let's have a look at the 2015 paper and see what this one looked like. Now this was the final question on what is probably the hardest C3 paper for years and years and years. So we've got this thing here, and we've got to simplify it to this thing here. So all the time we have this, there's two things we've got notes here. We can factorise the bottom of the right hand side there, but then we've got a number take away a fraction. We'll have a look at how to deal with that in a second. But if we factorise the right hand part of the function, we've got x minus 5k on the top, you've got x minus k on the bottom. Then we've got to factorise this bottom here, and if you factorise that, you can have x and x. It looks a little bit trickier because you've got k's in there, but that too much thinking. Oh, says he gets it wrong. You've got x minus 2k and x minus k. Now the minus 2k times the minus k is going to be plus 2k squared, which you've got on the end here. Minus 2k times x minus kx is going to give you minus 3kx. So you get this. And we can see, because all these questions are very, very similar, you've got to factorise either the top or the bottom, and then you can cancel out. So we've got that. But now we've got 2 minus x minus 5k over x minus 2k. Ooh. So in order to have a number take away or add a fraction, we need to have a common denominator. So we're going to times the top and the bottom on the left there by x minus 2k. It's going to be 2 lots of x minus 2k over x minus 2k. Then take away x minus 5k over x minus 2k. Now if we start out this left hand side, we're going to have 2x minus 4k over x minus 2k minus x minus 5k over x minus 2k. Okay, so now if we do 2x, change colour, 2x minus x, that's going to give us a single x. Minus 4k minus 5k is going to be plus k. And you've still got the x minus 2k on the bottom, and that's what it's asking for here. Hence find f dashed of x, given your answer in its simplest form. So we've now got to differentiate it, and just like last time, we've got a function divided by a function. So in that case, we use the quotient rule. So we're going to say that u equals x plus k. So du equals 1. Now that's because x differentiates to 1, and k, remember, is just a negative constant. It's just a negative number. And then we got, on the bottom, we've got v, which is x minus 2k. So dv, that just differentiates to 1. So we've got v du, which is x minus 2k, minus u dv, which is u plus k. And that's right, which is, let's try that again. So v du, which is x minus 2k, minus u dv, which is x plus k. But again, put it in brackets, all over v squared, so that's x minus 2k squared. So x take away x is going to be 0, minus 2k take away k is going to be minus 3k over x minus 2k squared. And that's it, that's f dashed of x. State with a reason whether fx is an increasing or decreasing function, justify your answer. So this is what f of x equals. Now we've got, if it's an increasing function, it's going to have positive gradients. If it's a decreasing function, it's going to be a negative gradient. So if we know that k is a negative constant, then this is going to be minus 3k times, and k is negative, so the numerator is going to be minus 3 times by a negative number. Therefore, the numerator is always positive. The denominator will be positive as it is squared. Therefore, whole of f dashed of x is positive therefore increasing function. That's what it means by that, whether or not it's a positive gradient or a negative gradient. So that was a 2015 question. Next thing you've got to have a look at is this one here. And again, it looks, we've got to we've got to show that f dash of x, so we've got to do this bit over here. Let's try it again. 2014, here we go. So f dash of x, so we've got to find the gradient function, and again, it's a function being divided by a function, and when you've got that, it's going to be the quotient rule. So we're going to say that u equals 4x plus 1. We're going to say that v equals x minus 2. So du equals 4, and dv equals 1. And it's v du minus u dv. So it's going to be v du, so that's going to be x minus 2 times by du, which is 4, minus u dv. And dv is 1, so that's going to be minus 4x plus 1. But again, remember to put it in brackets, because otherwise the negative signs cause difficulties. All over v squared, so it's going to be x minus 2 squared. Then we're going to multiply that out. So it's going to be, so this is f dash of x. F dash of x equals 4x minus 2 minus 4x minus 1. Oh, sorry, that's going to be 4x minus 8, sorry. So 4 times x is 4x, 4 times minus 2 is minus 8. All over x minus 2 squared. So 4x minus 4x, which is 0, minus 8, take away 1 is going to be minus 9. That's over x minus 2 squared, which is the first 3 marks. Given that P is a point on C such as f dash of x is going to equal minus 1, find the coordinates of P. So you've got to find out what x value gives us a gradient of minus 1. So what we do is we set our gradient equal to minus 1. And say that minus 1 equals minus 9 x minus 2 squared. So if we bring the x minus 2 squared up, that's going to be minus x minus 2 squared equals minus 9. Times both sides by minus 1, you're going to get x minus 2 squared equals 9. If we expand the brackets, x squared minus 4x plus 4 equals 9. Bring everything onto the left-hand side. X squared minus 4x minus 5 equals 0. So x minus 5 x plus 1 equals 0. Then x equals 5 and x equals minus 1. Now it says here find the coordinates of P, or given that P is a point, it's not a series of points, it's just one point. So therefore we can't have two x values. So what we do is we have a look, and x has got to be greater than 2, so therefore we don't accept that one. So we've got x equals 5. But it says find the coordinates. Now when it says find the coordinates, it means that we need the y coordinate as well. So what we've now got to do, and it's easy to get this mark, is put the x coordinate in to the original function. So stick x into the top function there, and that's going to be lots of 5 plus 1, so y equals 21 over, and then x minus 2, 3, therefore y equals 7, so the coordinates are 5, 7. And well done if you are now handy with differentiation.